Just getting your documents now. So what are we doing? Anything exciting tonight?
It's multiple choice.
Okay. Oh, I've seen these ones today already. Usually multiple choice doesn't help when you're doing verifying trig identities.
Yeah.
But these are a little different here. Multiple choice does kind of help here. You did 1 through 6 already? You wanting to do 7 through 12?
Yeah, I already got 7 and 10, so.
Okay, what about 8?
Yeah, 8, 9, 11, and 12, and then.
What's secant squared x minus 1 equal to?
Hold on, let me find a pencil. Secant squared x minus 1 is tangent squared.
Okay, now tangent is what? Relative to cosine.
Sine over cosine.
So what's the final answer?
Sine squared.
Okay, number 9. What is 9?
Would we have to factor this?
Yes, it's similar to many that we've done. So how are we going to factor it?
Secant squared x minus tangent squared x.
Times?
Secant squared x plus tangent squared x.
Yeah, it's difference of perfect squares. We don't usually think of cortex as difference of perfect squares, but it is. Now, what is secant squared x minus tangent squared x?
1. No.
Yes.
It is 1.
It is 1. So that goes to 1, and our answer is that. Now, it's worth noting that secant squared x plus tangent squared x is nothing. That is not an identity.
Okay.
Kind of like saying, what is sine squared minus cosine squared? That's nothing also. In other words, if it doesn't fit the exact format of that identity, then it's not equal to anything. By that I mean after the algebraic manipulation, but okay. You did 10. About 11. What's secant squared x minus 1?
Tangent squared x.
So this is tangent squared over sine squared. What is that? In other words, you're always trying to relate them to one another, basically. In other words, we could relate secant squared x minus 1 with tangent, and now we can relate tangent with sine and cosine. What's tangent squared quotient's identity?
Sine over cosine.
So what does this become?
Sine over cosine divided by sine. So
and most likely their answer is going to be secant squared x.
yeah.
This is a little bit like irrational numbers in the denominator. You don't ever leave it like this if you can turn it into a thing like this. You know what I'm saying?
Yeah.
In other words, we would never give an answer 1 over cosine or 1 over sine. We would always convert those to the reciprocals. All right, number 12. when you see pi over 2 minus x, there's really only one thing to think about or do to handle that. What does that equal to? It's a property of cofunctions. Every cofunction shares this property. What's the cofunction of cosine?
Secant.
No, not the reciprocal, the cofunction. Sine. Cofunctions merely mean you take that and stick a co in front of it. In other words, cotangent is the cofunction of tangent, cosecant is the cofunction of secant, and cosine is the cofunction of sine. And what they all share is that, squared or not, sine of theta equals the cosine of pi over 2 minus theta, and vice versa. In other words, cosine of theta equals sine of pi over 2 minus theta. So whenever you see pi over 2 minus theta, or x, think the cofunction property.
Okay.
That's equal to sine squared of x. The fact that it's squared doesn't mean anything.
Okay.
Okay. So we have sine squared of x over cosine of x. Sine squared of x over cosine of x. That's an interesting thing to simplify. Sine squared of x over cosine x. What can I do with that? Anything?
I mean, you could. I mean, the last answer we have.
Well, yeah, part of it depends on what's over there, and I'm blocked from seeing the right-hand side of that.
The final answer we have is sine x times tangent x.
That's the only thing left?
Yeah.
Sine x times tangent x. Okay. Well, what they've done is split the sine into this. And then they've separated that out and called that tangent. So I guess that is simplified. This is one case where the multiple choice really would help, because, yeah, I guess you can say that that is a simplification of that. It's two terms, but this has a squared term, so this would be proper, I guess. Okay, what next?
Just go to 14, 15, 16.
Okay. Which expression is equivalent to this? Now see, this is where I would just soon not have the multiple choice. And what is that? Oh, 1 over sine x?
Yeah.
In other words, the multiple choice doesn't help here. It would be an easier problem if they gave me the identity and said, prove that it's an identity. The fact that they make it multiple choice makes it extremely difficult. Let's see, what can we do? Let's see. Let's turn everything into, let's see, if we look at our answers, is there an E or is it just A through D?
A through D.
Okay. Well, the way I guess I'd go about it is to turn everything into sines and cosines and see what happens. Oh, that's inconvenient. I mean, that's convenient. Notice that that is 1 over sine. So now in fact, let's not turn everything into sines and cosines. Now that I turn that into sine, I can tell that it's going to be tangent squared of x over sine plus 1 over sine. So do that and simplify. In other words, once I do the multiplication first, now how do you add these two things?
Well, you can add them since they have a common denominator.
Okay, so what's the result?
Tangent squared x plus 1 over sine x.
Notice that I would have taken a step backwards by converting that into sine and cosine. It's much better this way because now I have something I can substitute for tangent squared plus 1. What is that?
Secant squared.
Secant squared. Okay. Is that one of our answers? Kinda. It's D. Notice that secant squared over sine x is the same as secant squared times cosecant x, the reciprocal of sine. You see it?
Yeah.
All right, let's look at 15. What are we going to do here?
Bring the 1 over to the left.
Now what are we looking at?
Quadratic.
Okay. Which means factoring.
2 cosine. 2 cosine minus, well, minus 1, and then plus 1 would be the other one, cosine x plus 1.
Does that work? Does that produce that middle term?
Yeah, it does.
No, it doesn't.
Nope, yeah. No,
Check
it
the
doesn't.
insides and the outsides. That's all you need to check is the inside and the outside. But it produces a plus 1, which means is all we got to do is change the sign here, make that a plus, make that a minus, and it'll work. Now it's plus a cosine minus 2 cosines gives you a minus cosine in the middle. Okay, now what?
Set them both equal to 0.
So we got cosine x equal 1. What is x? In the 0 to 2 pi?
Right now, let me find it. This will be a 45.
No?
Yeah.
Notice that whenever we're dealing with 1 or 0, we're dealing with a quadrangle. We're dealing with either a 90, 180, 270, or that's it.
So this is when we deal with the graph, right?
Exactly. And this is where you have to access the cosine curve. You need to be able to create that from memory, not by looking at a piece of paper that's got it drawn on it. Both the sine and the cosine curve you want to be able to create. There's the cosine curve. Where is it equal to 1?
At 0 degrees and...
Actually, just there. Also at 2 pi, but notice that 2 pi is not in our domain. It's got to be less. It's got to be less than 2 pi. Okay, so the second part of that answer, we have to solve that, which means cosine x equals what?
Negative 1/2.
Which occurs where?
It occurs at 90.
No. This is a number that is not 1 or 0, which means it can't occur at a quadrangle. Notice that both your sine and your cosine curve, all of the key points happen at the quadrangles, the multiples of 90. Well, half is not a key point. Half is what sine of 30 degrees is equal to, which means cosine of what is equal to 1/2? Based on the cofunction property.
30.
60. In other words, sine of 30 is going to be the same as the cosine of 60. So a 60-degree first quadrant angle is what we're dealing with. Which quadrants is cosine negative in?
Second and third.
What's the second equivalent of
120.
60? 120. And what's the third?
240.
Okay. There's your 3 answers, except all of our multiple choices are in radians. So this is the way I convert to radians. I don't really do it normally. This is 2 of those, so this has got to be 2 pi over 3. And this is 4 of them. This is 4 pi over 3. So our answers are 0, 2 pi over 3, and 4 pi over 3. B.
Okay.
Now, I figured out the first quadrant angle. That's not one of the answers, but that's the way I figure out the second and third, is by always figuring out the first. The teacher may not do that, I don't know. Cosecant x plus 2 equals 0.
Cosecant x equals -2. And then
There's also choices on how to handle this. I always do this a certain way, but it's not to say that you have to do it that way. Do you know where the cosine of x is equal to 2? The cosecant of x, I'm sorry.
I do not have that graph
Well,
memorized.
the better way to do this, I think, is what's the reciprocal of cosecant?
Sine.
So if the cosecant of x is equal to -2, what is the sine of x equal to?
1/2.
-1/2.
-1/2.
It retains the same sign. In other words, these are reciprocals of one another. And the reciprocal of a number is always the same sign.
Okay.
Okay? So we know that we're looking for this angle where the sine is equal to -1/2. Well, where is that?
Sine of 1/2 will be 60 degrees.
No,
30.
which is pi over 6. So which quadrants? Is it going to be -1/2?
Third and fourth.
So the third is what?
210.
Okay, they want it in radians. Notice that instead of 180 plus theta, let's use the pi plus theta. which immediately gives us 7 pi over 6. Because 180 plus 30 is the same as pi plus pi over 6, which is 7 pi over 6. So it's a little bit easier to me to do it that way than it is to multiply that whole thing by pi over 180. I'm not sure why, it just is. And so that's one answer in the third quadrant. What's the fourth quadrant?
330.
And the way I look at that is 360 minus 30. Well, 360 is 2 pi minus a pi over 6. That's got to be 11 pi over 6. So our answers are 7 pi over 6 and 11 pi over 6. B again.
And then I sent you a picture for the next page.
Yeah, I've got it, I think. That's this one here, I believe. Is that the next page? No, that was that page. What's this one? I got to turn it.
I finally got good lighting for my pictures, so now they're clear.
Yeah. Okay, what are we going to do on the first one? What's that going to be equal to?
Pi over 2 minus x.
Remember, whenever you see pi over 2 minus an angle, it's a cofunction property.
So the cofunction of sine is cosine.
Exactly. That means that's cosine of x. Simplifies everything. And you got to do it that way because otherwise we have no way of doing any of these. If it's not the same angle, you can't use any of these identities. So that's the very first job when you see a pi over 2 minus x or a 90 degrees minus x is convert it to its cofunction. Now, what are we looking at? I'm not even going to look at the answers. You can see what's cosine over secant equal to?
Cosine squared?
And what's sine over cosecant equal to?
Sine squared, so the answer is 1.
Uh-huh. B again. Heck with the session. Just answer B to everything.
Well.
Okay, tan x plus cotan x over secant x. Let's just look at our answers. We got a cosine, sine. Okay, that's not much help. Notice that if we add the top, we'll have tangent x plus 1 over tangent x. What kind of numerator is that going to result in?
It'll be 1. Oh, no, never mind.
It'll be tangent squared plus 1.
Yeah.
Magic number.
That turns into secant.
Yes, which is particularly magic because we have a secant in the denominator. So this numerator turns into tan squared of x plus 1 over tan x and divided by secant x. Well, that's secant squared. Flip and multiply, and I have secant over tan. What is that, since they don't have that answer on? Ooh. Secant over tan. Let's see. That is 1 over cosine divided by sine over cosine. Cosines cancel. That's,
Yeah.
go ahead.
1 over 7.
Or cosecant.
Yeah.
D. Again, they're never going to have an answer that's 1 over sine. At least I don't think so. Okay. What are we going to do here?
You can simplify cosecant x plus 1.
No, not unless it's squared.
Oh, yeah.
These are harder to deal with when they're like this. Whether it's cosecant or sine or cosine, there's no identities that are equal to that. But what are we looking at there? What is that?
We need common factors.
That's the difference of squares that's been factored. Well, if we tried to subtract these two fractions, we would have to find a common denominator, right?
Yeah.
What is it?
Cosecant x plus 1, cosecant x minus 1.
It's cosecant. Well, it is, but after we multiply that together, it's difference of perfect squares. And the reason I do that is because now we can substitute cotangent squared for that. But before we do, let's fix the numerators. We got sine x times cosecant x minus 1 minus sine x times cosecant x plus 1. May or may not be the way to go. Let's see, so if I replace that with cotangent squared of x, am I making any progress? A little bit. I can replace cotangent squared of x with cosine squared over sine squared. Now it's just getting uglier. No, it isn't getting uglier. Or is it? I see this 2 sine cubed x. In other words, if I flip and multiply, I'm going to have a sine cubed of x. Let's do that. Let's flip the bottom and multiply. We're going to have a sine cubed x cosecant minus 1 minus a sine cubed x cosecant x plus 1 all over cosine squared. With me?
Yeah.
Well, let's factor out a sine cubed from the numerator. What is left behind? Cosecant minus 1 minus the quantity cosecant plus 1 all over cosine squared. Okay, well, this cosecant cancels with that. And I have minus 1 minus another 1, so I have minus 2. So I end up with minus 2 sine cubed of x over cosine squared of x. B. What'd I tell you? We could have saved the session. Just B on everything. So far, haven't we done 5 straight that have been B?
No, one's been D.
One's been, oh, you're right, the last one. Yeah. All right, let's try to do this one here. Oops. Ugly. What the? Cotan x plus cotan x. Not that ugly. What can I do to that expression?
Factor.
Yeah, well, notice what gets left is something that can be turned into a single thing. What's
A cotangent squared plus 1 would turn into cosecant.
cosecant squared? So now let's see if that answer's on there. It is. Hold on. I get cotangent squared cosecant squared. They got negative cotangent squared cosecant squared. Cotangent squared plus 1. Ah! That doesn't turn into cosecant. Oh, yes it does. Okay, well, this isn't the answer right here, so it must be one of these others. Let's keep manipulating this thing. Gosh, how? Could it be that? Yeah, it could be that. Let's start with here. And now substitute for cotan squared. What's cotan squared equal? Right?
Yeah.
Times cosecant squared equals cosecant to the fourth minus cosecant squared.
That's 1.
B again. That's kind of interesting. That the sum of those two is equal to the difference of those two. Some of these trig identities turn out to be awfully strange. You tell me if you want to keep going or not. We're at the half-hour mark. I'm perfectly willing if you want.
No, half hour's fine.
Okay, sounds good. I think you understand this stuff pretty good. A lot of times it's just a question of seeing something. That wasn't that easy to see, but it just seemed like it was a weird thing to have to do, is to go back in the other direction. But that's what we had to do.
All right. Thank you.
Jackson, I will talk to you tomorrow night.
All right. Thank you.
Bye-bye.